All right, so let's do some calculating. Welcome to Unit 5.2. We're going to talk about calculating molar mass. We'll start here. What is that? Right. So what is the molar mass? Remember, the molar mass of something is the mass of 1 mole of that substance. And the way we calculate it, especially in a compound, remember a compound is 2 or more elements, but we calculate by adding the atomic weights of all of the atoms in the compound, which is sometimes called the formula weight. So that's the weight of the formula, right? Which we'll do an example of that. Why do we do this? So we want to calculate the molar mass of a compound so they can convert that mass to the number of moles or the number of molecules in a sample. And you'll see when we talk about chemical formulas how that works. But basically, like we said in the last lesson, it's a whole lot easier to do these calculations when you're talking about 1 mole or 2 moles than when you're talking about big numbers like 6.02 times 10 to the 23rd. So here's a quick example of how we calculate the molar mass. We are going to use barium nitrate as our example calculation. If you remember from the last unit on how to figure out formulas, we have barium, which is Ba plus 2. You look on the periodic table, it's in that second group, second column. And nitrate from your reference sheet is NO3, and it's a -1. So when we write the chemical formula for barium nitrate, we have plus 2 and -1, which means in order to even it out, I need 2 of these. Then we have plus 2 and -2, which means the chemical formula from barium nitrate is 1 barium, 2 nitrates. So that's the formula. Okay? Which is why we are looking for the formula weight, because it's the weight of this formula. So when we're calculating this, that's the first step. Find the chemical formula. The next step is figure out the number of each of these atoms that are in this formula. Well, barium is easy. There's 1 of them. Right? The nitrogen is in these parentheses, so that means, just like we showed up here, there are 2 nitrogens. 2, 1, 2, 1, 2. So there are 2 nitrogens. The oxygen, even a little more complicated, there are 3 of them in each of these groups. So there's 3 oxygens here, there's 3 oxygens here, for a total of 6. 3 times 2 is 6. So we have 6 oxygens, 2 nitrogens, and 1 barium in this grouping right here. So the next thing we do is we look at our periodic table and we find the atomic weight of each element, and we multiply that by the number of atoms. So for barium, there's 1 of them, and we find the formula weight on the periodic table, or the atomic mass, or it has a million different names. But barium is right here, and you can see the mass is 137.32. So 137.32. Then for nitrogen, there are 2 of them. I find the weight of nitrogen is 14.01. So this time I have 2 times 14.01. And then the oxygen, there are 6 of them. And the formula weight of oxygen is 16. 16. So we go 1 times 137.32. That's easy math. 2 times 14 is 28.01. And then, actually, 02, sorry. 2. And then 6 times 16 is what, 96? So this is the weight of all of these atoms. The 1 barium, the 2 nitrogens, the 6 oxygens. Then our next step is to just add all that together. 137 plus 28 plus 96. And we get, let's see, I got to add it. 2 and 2 is 4, then 3, and then 21, 7. 7 and 9 is 16. So I get 261.34 grams. Per mole. Okay, so the weight of barium nitrate with its 1 barium, 2 nitrogen, 6 oxygens, you just add it all up. And we get, if on this little scale here, 261.34 grams. That is 1 mole of barium nitrate, and that is how much it weighs. So when you're doing these molar mass calculations, that's all you need to do. Figure out the number of atoms, figure out how much they all weigh, and basically add it all together.